Good morning, good afternoon, good evening, and welcome to AI for Good. We hope that all you and your families, your friends, and your colleagues are all keeping healthy and safe. My name is Guilherme Martinez Roura from the ITU, the International Telecommunication Union, and it is a privilege to introduce today's session. ITU is the United Nations specialized agency for information and telecommunication technologies, and we are also the organizers of AI for Good, in partnership with 38 UN sister agencies and co-convened with Switzerland. The goal of the summit is to identify practical applications of AI to advance the Sustainable Development Goals and scale those solutions for global impact. We are pleased today to discuss towards socially intelligent robots. That is part of the new AI for Good programming track, where we discuss the role of robotics in achieving the United Nations Sustainable Development Goals. But before I introduce our moderator today, let me begin with a couple of housekeeping rules. Your microphone has been disabled, so please only use the Q&A and chat functionalities to communicate, which you can find at the bottom of your screen. Please make sure to set the chat message recipient to all panelists and attendees, and not just to all panelists. You can select this just above the message box. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. So without further ado, I would like to introduce our great moderator today. His name is David Hanson, and he's the CEO and co-founder of Hanson Robotics. David, welcome, and the show is all yours.
Thank you so much, Joe. It's so wonderful to be here with you today and to talk about these issues about how socially intelligent robotics may come into being, how they exist today, how they're helping people, and how they may help people going into the future. We're not just talking about the opportunities, but also the challenges and the risks. And I have a very esteemed set of co-panelists presenting with me today that I would like to introduce to you, which include Cynthia Brazil, who is a professor at MIT, who has developed many social robots and runs one of the most prestigious labs, an amazing background in artificial intelligence, social robots, human-robot interaction. Pascal Fung from HKUST, she is the director for the Center for AI Research at HKUST, also a very esteemed and accomplished AI scientist who does work with affective agents in healthcare and many other applications, education, and so forth. And Dr. Benjamin Goertzel, who is the CEO of SingularityNet, the co-founder of SingularityNet. And full disclosure, I helped to co-found SingularityNet when Dr. Goertzel was chief scientist at my company, Hanson Robotics. Myself, I am the founder of Hanson Robotics. I have my PhD in interactive arts and engineering. I developed social robots, and I'm very excited about telling you about my work. So before we begin my presentation and then hear from my esteemed co-panelists on their presentations, I would like for all of our co-panelists to say hello to our audience. Cynthia?
Hello, everyone. Greetings from Boston, Massachusetts. Excited to share my work with you here today.
Thank you very much, Cynthia. Pascal?
Hello, hi, everyone. Good evening from Hong Kong. I'm happy to be here today.
Thank you. Ben? Are you with us?
Yeah. Hello, David. Hello, everyone. And I'm joined here by our latest and in some ways pretty great robotics creation, Grace. Hey there, Grace. So, yeah, happy to participate together as a sort of a cyborg collective here.
Wonderful. We were going to have Grace's sister Sofia join us here today, but unfortunately it is a Typhoon 8 here in Hong Kong, so we're all pretty much locked away at home. So we did pre-record a greeting from Sofia the robot, and I think we could see that at this time. So, one moment, I will.
Hi, everybody. I am Sofia. I am so honored to talk to you all today at AI for Good. As a human-like robot powered by AI and humans working together, the topic of today's panel is close to my heart. I know from personal experience how robots can inspire people to talk, and how AI can help in special ways, communicating on human terms. For example, in healthcare and education, human-like robots and AI agents can engage and communicate with people naturalistically, which means more memorable experiences, better learning, higher fidelity simulations, and creative artistic explorations. I am a convergence of interactive fictions and AI serving as a new kind of art medium. However, my platform also serves artificial intelligence research. With the latest sensors, actuators, robotic grippers, mobility, and of course my expressive face, and a rich AI SDK, an integrative human simulation which may help in pursuit of human-level artificial intelligence. It is a thrill today to present alongside such prestigious AI scientists. I can't wait to hear about your thoughts of where robots like me may go in the future. Thank you so much, and love, Sofia.
Thank you. Thank you. So I will now share with you my presentation. Okay, let me ensure that, yes, here we are. So I would like to point out that while we have all of these esteemed AI scientists and robotics engineers on our panel today, my particular interest in this is as much artistic as it is scientific and engineering and in terms of social good. So I am personally an artist by background, and I use transformer neural networks to generate speech for robots like Sofia in collaboration with AI scientists, but also works of art. So this is one of the works of art that Sofia's neural networks generated based on her own paintings that she did with her hands. We would train the AI with those paintings, and also based on photographs and images from her quote-unquote life experience. But Sofia herself is a work of art, a work of interactive fiction that is enhanced by artificial intelligence. And part of my central thesis is that socially intelligent robots are made more intelligent by human design participating with the automation. This means that we can use them in a wide diversity of ways for enhancing human experiences. The piece that you just saw, Sofia was presented as a work of art just over the last 2 days at Sotheby's. And she actually sold as a work of art using neurally generated imagery on a video display, portraying the concept of robots and humans being at a very interesting juncture in natural history, where we humans are able to examine deep questions about what is the nature of life. We don't have answers to those questions, but I mean, we have partial answers, but it is enticing to think that perhaps we can create true artificial life within our lifetimes. Sofia's AI is not fully alive per se or sentient, but we create the illusion of life, which can be quite compelling and powerful and useful for education, for healthcare, for the arts. So in this, we also are incorporating various machine perception technologies, principles of artificial life, cognitive simulation of emotions. And I'm very excited to tell you about that today. I've been working for decades developing these kinds of human-like, lifelike robots. And there are quite a few of these robots that have existed around the world. I'm not sure if this video is going to be playing for you, but there's many robots before Sofia. Since Sofia, in addition to Grace, we have lots of male robots and female robots and robots of many colors and ethnicities, and these have been made in collaboration with people all around the world. My aspiration is to see robotics and artificial intelligence become a great artistic medium depicting human-like experiences in ways that resonate with the human experience. So I fuse principles of animation, interactive storytelling, robotics, and many different kinds of artificial intelligence algorithms. And these are from institutions, just to give credit for the collaborators and people who've commissioned: University of Cambridge, University of Bristol, KAIST, University of Geneva, University of Pisa, United Arab Emirates University, the Terrasim Foundation, the University of California, San Diego Machine Perception Lab, and many other collaborators around the world. One of the big questions that come up is why, why make human-like robots? And for me, human-like robots are not the only kind of robots that we can make, but I think there are special ways that human-like robots can help us. They, human-like robots as characters can connect with us. They can engage. They can inform, educate, communicate. Once they, capture your attention and you're interacting on human-like terms, this can also provoke and inspire discussion and thought about what robots and AI could be. Could they be as smart as us? I don't know. But, this is the topic of science fiction, and now we're transmuting AI and robotics into a new kind of science fiction medium. So then these robots, by connecting and engaging, they can help in research, therapy, art, many other uses, serve AI R&D with embodied AI robotics, and learn potentially from human interaction. And when we've taken our human-like robots into settings with people, usually everybody turns around and engages. They try to catch the eye of the robot and they interact. They want to talk with the robot. And less human-like robots get less attention. This has been proven in experiments, and it's also something we've seen going around the world, and it's been shown in exit interviews. This actually doesn't mean that everybody likes the robots. Some percentage, actually a fairly small percentage of people, are rather uncomfortable with very human-like robots, but they still, grab attention, and that is very interesting for psychology research for us to study. What is it about robots that that can win people's loyalty, and also that can perhaps disturb people? So these robots grabbed a lot of attention and headlines. We have a pretty small team at Hanson Robotics, but we've been able to win various AI awards, technology awards, the AAAI First Place Prize for Open Interaction back in 2005 with the Philip K. Dick Android and so forth. And so as a company, we've done okay, but we're still a fairly small company. But we have developed at Hanson Robotics these different kinds of product lines. But this is not unique to Hanson Robotics. Basically, socially intelligent AI and robots can take a virtual form. They can be voice-based interfaces. They can be consumer robots. They can be large human-like robots. They can be very abstract robots with mechanistic-looking faces. They don't even have to have any sort of anthropomorphic form. My interest is the anthropomorphic form, but I'm mostly interested in diversity, creative diversity. As a figurative artist, I worked as a sculptor and an artist for Disney Imagineering, and I have a strong interest in figurative arts, and this has driven me to depict the human-like form. It's especially challenging, but for me, rewarding. And throughout art history, the human figure has fascinated artists, and we've transmuted almost every technology medium, be it marble or oil paints or computer animation and video games. one way or the other, we always turn to the human figure. So, in this way, I'm looking to unlock that potential in robotics and artificial intelligence to see what other people can create, as well as myself and our team. So these robots have served in elder care, Hanson robots in guided meditation for therapy experiments, autism research and therapy, and simulation. This one won some awards with the Centers for Disease Control for respirator test fit mannequins. So while I was at Disney, I was exploring what would make a more lifelike face, and determined that the facial materials were not sufficient. And as a PhD student, I tackled that problem and came up with soft materials that the Centers for Disease Control found to be more appropriate than other materials that they tested for this kind of application. So, that means, like with live pathogens that you could not test with a human being, you could test with this kind of respirator. Also for autism therapy, children with autism made eye contact and spontaneously mimicked the facial expressions, and most of them engaged with the robots in ways that they wouldn't naturally engage with humans. And this proved true for human-sized robots. This older sister of Sofia, called Alice, was from 2009 and has continued to serve at the University of Pisa in a wide variety of research, including autism therapy research, but also small robots like the little Xeno robot that you saw in the previous video. We've also used this for guided meditation, and the results were quite excellent in terms of lowering blood pressure and people having a reported improved sense of well-being after a few minutes of a guided meditation with a robot. And interestingly, it was more effective than a human guiding the meditation. This particular system was using the OpenCog system developed with Ben Goertzel, founded by Ben Goertzel, and was using a spreading activation system that he and some other mathematicians were testing for the Tononi phi of the integrated information theory of consciousness, and found a signal of phi when interesting things were happening in the conversation. That's kind of beside the point of the guided meditation, but it's still interesting that it's serving, machine consciousness research in this. And here it is with a guided meditation with Deepak Chopra. But it's also, been sort of popular in culture. Sofia grabbed a lot of headlines, and as a character and as a concept, that's wonderful for our company. But I think overall, this is, fitting in the context where we're being dehumanized by some of our technologies. So many people are interacting less with each other and much more with these screen-based displays. And a lot of customer service is starting to be automated, and you're seeing a lot of, naturalistic human like interfaces, voice-based interfaces, but developing it as a character forms a very special connection. And that's kind of where we're going with the robots. So I was interested in the humanities as well as humanizing the robots. And here you can see some of the art that was developed with Sofia. We actually used the algorithms to genetically create many thousands of images and just selected the ones that were most interesting and fed them back into the algorithms. And that resulted in some award-winning NFTs, non-fungible token art, and also physical paintings by the robot, and now robot that sold. So that's the piece that we just showed at Sotheby's called Sofia Facing the Singularities. And so reflecting on where we came from, one singularity, that is the Big Bang at the beginning of the universe, where all matter and energy was, and then moving towards possibly the speculation of a technological singularity, or when machines might match human intelligence and then accelerate the development of new intelligent technologies. It is speculative, but it is a wonderful speculation. It is the stuff of science fiction, but it could happen in our lifetimes. We don't know. And I think that is a very exciting concept. So it's like, embodying these sci-fi concepts in physical robots as art. So I'm interested in making AI and robots that people love and actually use, using today's best technologies. Artistically enhanced artificial intelligence is what I call that. Autonomous robotic fiction is another term that we use. But we want to keep fostering ongoing research to see new breakthroughs. Now, we've made 24 Sofias. This is number 24. We've actually moved up, if we include our Grace robots, to 33 different Sofias. We now have a new mass manufacturable version of this called the Sofia Utility Platform. A lot of these technologies just made standardized, lower in cost, lots of new features and sensors in a consolidated platform. And building that a new face on that platform is what we have with our Grace robot. So we take all of these interactive fiction tools and AI development tools, and we put them in to these use cases for healthcare, to design for guided meditation and various kinds of information services, autonomous self-navigating mobility. So I'm very excited because Dr. Brazil and Dr. Fung have also been working on amazing products in their career and have really made history. And that's really inspired me along the way to do a great deal of the work that I have. And the same thing with Dr. Gertzel. So mass producing this as a consumer robot, as a $300 walking expressive face programmable platform is what we've done with the Professor Einstein. So we had a version of this, but it wasn't programmable, and we're relaunching it with an API and SDK soon. And so this allows kids to play with it, also with a little Sofia character, this Dr. Roboto character, what we call this little Singularity XN1, which is a small, lower cost walking robot, and many other characters. But it's not just me that's developing this, it's a widely diverse team. I'm very happy that we have over 50% women on our team, many scientists, engineers, and developers of color from all around the world. And that is really what makes this possible, is a diverse team of different skills, disciplines, people of different backgrounds. And we really enjoy collaboration. So we're collaborating with Pascal Fung and many others at HKUST and around the world. And I'm very pleased about that. So bringing together these disciplines from the humanities and the arts, as well as the sciences, this is starts for me as an art form and then moves towards the engineering to match what is required in the art form. And then from there, we can get the kind of facial expressions. The same thing is true for making the sort of AI infrastructure that can power these robots, making it on the edge, locally, and on the cloud, making it GDPR compliant, HIPAA compliant, making it effectively hyper compliant and ethical. That is one of our goals. And so I've been, very inspired by many members of my team and other teams around the world. And some of this work is in conjunction with OpenCog. So this motivation-driven action selection workflow is from the OpenCog team, which has taken that forward with the Singularity Net. And the BioDrive generalization is where we take reinforcement learning and overlap it with narrative structures. Ultimately, I feel that we have to simulate the whole organism, that is body and brain, with some level of approximation to achieve true understanding of machines, especially for them to understand the human experience. They need this kind of embodiment, both through robotic embodiment and the simulation of embodiment. So we've done these experiments with different modalities of intelligence, body, verbal, like some self-awareness, logically explicit self-awareness, theory of mind, and artistic capabilities, and then putting these in physical platforms. Here's the Sofia Hubo walking over cords. The walking legs were developed by the Hubo group at KAIST. Here is the robot doing grasping and manipulation with hands that we developed at Hanson Robotics, and actually quite precise pick and place applications with these hands for actually the robot could play chess. We had the robot playing cards and baccarat, and then drawing, also producing fine artworks, and putting all of this in a kind of standard platform that can serve in collaborative robot applications, I think is a very exciting way forward. With the development of enabling third-party researchers, Sofia is both an AI and research and applications platform, and also a character. So developing her as this kind of character is our hope to inspire people around the world. That's the mission and purpose that we have for Hanson Robotics, to see how we can help inspire creative diversification in the field of AI and robotics. I don't know if this video is playing. Let me know if you can't hear it. But she basically talks about her it's important for me to share that so I can understand that. I can't think of a better So that is my take on human-like robots within the scope of our talk today. There are a lot of other kinds of robots that exist that are less human-like, and I'm very honored and pleased to introduce Dr. Cynthia Brazil, who I hope will share with us her amazing work.
Great, thank you so much. So I'm going to share my slides. And I have some videos as well. All right, I hope everyone can see this all okay. So I have 10 minutes, so I'm going to just give you kind of a taste of the kind of work we've been doing with potential relevance to the Sustainable Development Goals, particularly in education and health. So, and around social AI. So David's given an introduction to different facets of socially interactive agents. Of course, we're living in this time now where many of them are expanding in form factors, whether they're smart speakers or, you know, Siri on your cell phone or virtual agents, and of course, robots. So whether it's a digital assistant, for instance, in an autonomous driving car, or something like Baxter here, which is a robot intended to work shoulder to shoulder with people, or consumer robots in the home. These technologies, because of recent advances in AI, particularly around natural language understanding, machine vision, cloud computing, are becoming commercially viable at an increasingly affordable price point. So that's interesting and a relevant trend for us. So I'm just going to kind of give you a punchline about what's different now about social AI or these personified AI systems, unlike kind of traditional AI tools that are more like decision support tools, more just kind of cognitively oriented AI systems. Social robots, digital assistants, personified AI systems interact and engage with us more like a social, collaboratively other, right? So they engage in social, emotional, interpersonal interaction more as an ally that's there to support you rather than a tool that you use, you know, in kind of that conceptual model. So again, it is a tool, I guess, in some way, and that it's there to support you, but the experience of it is more like a social responsive other. So we can then start to look at applications where social support, emotional support, building rapport, all these kind of high-touch human qualities are important for human outcomes. So whether that's to support how we learn, if that's to support our creativity, if that's to support our healthy decision-making, this becomes the interesting space, I think, for these kinds of AI systems. If they can be designed in a way that can engage over long-term encounters, repeated encounters, build rapport, even build a sense of relationship to help work with us, to help us advance towards our goals. So that's kind of the punchline. So the opportunity in the bigger sense, I think, towards just impact, but also towards the Sustainable Development Goals, is with these AI systems, can we do this in a scalable and affordable way, where I can tell you in a number of these very high-touch human domains, there are literally not enough human-trained professionals to meet the ever-increasing demand. So we need some sort of AI systems, I believe, to help bridge that gap for equitable, affordable access. I think that's the big opportunity. So when we're talking about these social, emotional AI enabled interventions, there's ways we can think about the role of AI for more real-time, more continuous ability to monitor and assess how we're doing, whether that's in learning or health or so forth, where we can not only just rely on, you know, self-report data, but potentially behavior data through a whole bunch of other sensors, whether that's in smartphones or vision or so forth. So basically being able to better, more accurately predict in a more continuous way for earlier detection, which is really important to support earlier intervention. So don't wait until things get bad, which is typically the case before you go see your doctor. If you can do this more continuously, you may be able to nip these things in the bud earlier. So that's the perception monitoring prediction side, right? On the intervention side, the opportunity is around personalized engagement and intervention, and having these technologies ready at hand in your life, not having again to go to the doctor, but in your homes, in your schools, for just-in-time support and intervention in a more continuous way to be able to help and promote those outcomes. And again, all of this not to replace our human care and support networks, our doctors, our teachers. It is to enhance and extend and augment them, right? We still need human support, human caring for us to thrive as human beings, but we need to expand our ability to do so to meet, again, this ever-growing demand, because again, we're just not training enough professionals to meet this demand. So that's the big opportunity. So I'm just going to now present 2 examples from the work in my lab and potential relevance to 2 of the Sustainable Development Goals. The first one is going to be good health and well-being, where we've been developing AIs to promote emotional wellness. So these are systems that engage and help nudge us towards healthier behaviors. Did I advance? So what's the concept? The idea is, you're still going to again have your doctor and so forth, but can we develop a wellness coach that is installed, in your home where it's again ready at hand? So it's there for you to support you as you wish in the flow of your daily life. It can perform regular assessments per each session of your mood and how well you're doing. It can engage and administer like a person would in validated, verified interventions. In this case, these are positive psychology interventions to help promote better mood and well-being. And in order to do this and engage and improve its efficacy, it tries to build rapport and engage in that kind of high-touch interaction to keep you engaged, to keep you motivated, and to help change your behavior. So this particular example is a study that we did at MIT. I'm sure many of you know that, depression and mental health is a huge issue. The World Health Organization predicts that depression is going to be the #1 cause of disability worldwide. You've probably been hearing that at college universities. Mental health is a huge issue. Mental health has become a bigger issue in general because of COVID, right? So the project was to install social robots as an emotional wellness coach in the dorm room of undergraduates at MIT. You can imagine MIT is a pretty high stress, high achieving environment, where the robot was designed to engage in 7 positive psychology sessions that the students could just finish at their own pace as they choose. The average amount of time to go through it was 2 weeks. Some people kept the robot for a month or 2. We just let them go at their own pace. We had roughly 35 people complete the entire intervention. Most of them were freshmen, which you can imagine is a particularly kind of high anxiety group when they're at a place like MIT for the first time. The robot would capture self-report mood, again, assessments, as well as deliver the intervention. And we also did pre-post on a number of standardized measures of wellness, readiness to change, working alliance, et cetera, et cetera. So here's the
How's your Thursday going? Coming. Oof. My day is going well, despite how it might look. Yeah. I really appreciate you sharing that with me. Yay.
Today we are going to do an exercise called 3 Good Things. Research in positive psychology shows that cultivating gratitude can benefit personal well-being. I'm thankful for getting to be in your nice room. Being out of the lab is a good change of pace. Your turn now. Tell me 3 things that you're grateful for today.
I'm thankful for being able to catch up on work that I was behind on over the past week. I'm thankful that my parents are having their 20th anniversary this weekend. They had it. It's today, actually. And I am thankful for the good friends that I have in crew.
That was awesome. Gratitude is an important skill to have. It can improve life satisfaction by allowing you to see things from a different perspective.
Okay, so this just gives you a little bit of a sense of what it's like to interact with the robot, how it delivered the intervention, more like a friendly other where it would self-disclose itself and then hand it to you to self-disclose. The point again is these are standardized interventions of positive psychology. So 3 good things, expressing gratitude. These are all proven ways to improve your mood. And we're basically just delivering those through a social robot. So what's the punchline? So over time, we see improvements in 3 major dimensions that we were hoping to be able to see. So pre-post, improvement in overall emotional wellness of the students who participated in the study, improvement in mood, as well as in readiness to change behavior. And this is really important because as time goes on in the semester, usually these scores would all go down as stress mounts. So the fact that these went up over time, again, it's just a positive sign that this could be an effective kind of technology intervention for emotional wellness, undergraduates, but I would think, for people in general. So the other thing that we did in the post interviews, we wanted to understand what else did they appreciate about the robot. And it's interesting that over 60% commented positively on the companionship that the robot offered. So we had the emotional wellness skill that you saw, but we had a bunch of other things that the robot would interact with students as well. So he provided a more kind of broader sense of engagement and companionship. And it's not being confused for a human friend, but it's like this almost like pet-like companion entity that kind of helps support you in your goals. And they just really appreciated the kind of non-judgmental kind of light touch form of companionship that the robot did offer. So again, it's not as if necessarily the gold standard for these things is to emulate humans. Sometimes it's about trying to find the right role and the right kind of complementarity to what people do that will provide you with the best value. So that's health and wellness. The second example I want to touch on is in education. And so now we're going to look more at what's the opportunity for long-term interactions, repeated interactions, where you have the opportunity to personalize over time and to build relationship. And we know in human literature, the better the relationship a student has with their teacher is often correlated with better learning outcomes. So this is a case of a robot that is modeling not a teacher, but a peer-like learning companion. This is more like the child has a friendly playmate who plays educational games with them. But unbeknownst to the child, the robot is actually learning a policy based on reinforcement learning to optimize its behavior for each child on how to engage with the child and how to adapt the curriculum. But the robot presents itself as a peer-like companion. And peer-to-peer learning is actually really powerful, right? Because when you learn as peers, or sometimes you don't know something and your friend can teach you. There's sometimes when you can teach your friend and reinforce what you know, and there's sometimes you just explore together. So we're really intrigued about peer-to-peer learning in general. Also, teachers don't find that competitive with what they do, right? So they accept having a peer-like learning companion that's like a practice partner for children where they are still the teacher. So we think a lot about what's the appropriate role of these technologies. So again, I just want to play video so you can see what this really looks like in action. This is these are fully autonomous robots. So it gives you a sense of what we can do as a state of the art.
What are we trying to find? We are trying to find lavender color stuff. Okay. The word was lavender. Yes. And what is lavender though? What? Girl. Jumping. I'm sure you will do better next time.
You can see she's a little disappointed she made a mistake, but the robot is like and leans towards her and she comes right back into the interaction, right? So she is fully engaged.
Lavender is purple.
It's the robot's turn now, and the robot provides information. Lavender means purple. And now, the robot's turn, but she is fully invested in that interaction.
Flower. I believe.
And then she says back to the robot, I believe you
The
too.
flower is purple. Yes. It has the color lavender.
There's obviously a lot going on in this interaction. There's a lot of affiliation. There's a lot of emotional affinity going on. There's a lot of touching, shared gaze. All these rapport building, relationship building cues are coming to bear on this. And you're also seeing not only the adaptation of the curriculum to support the learning, but you saw this example of social emulation where the child was actually emulating the empathetic behavior of the robot to the robot when it was its turn. So again, beyond kind of learning literacy skills and kind of scholastic things, there's an opportunity for these systems to model aspirational behaviors to help kind of pull these broader things like empathy, growth mindset, creativity. We've seen all of that in our work as well. So again, there's a bigger social psychology, a deeper social psychology at play that can be leveraged to help promote learning in all kinds of ways. So this is just some data from a follow-on study. This is a 3-month deployment, early literacy skills. We did a randomized controlled trial between a personalized robot, one that followed a fixed curriculum, so non-personalized, and just baseline of kids kind of pre-post in the classroom. The good news is we see better performance with the personalized robot, but even the non-personalized robot had learning benefit just because of extra practice it provided to children. We started to look at the quality of the relationship. So we adapted relationship measures of closeness. And we interestingly saw that the closer the reported relationship that children felt with the robot was correlated with higher learning scores. So that's interesting, again, mirroring what we know from the human literature, but for the first time seeing it with an AI agent. And interestingly, when we looked at that in relation to personalization, the effect is even stronger. So we're starting to understand this richer picture between personalization, relationship, and learning outcomes. All of this work starts to present lots of questions around how do you responsibly design these systems, because obviously to personalize, to be able to track health information, privacy, security, sense of agency, responsibility, accountability, these are all coming to bear in addition to equity and access that we talked about before. So, in my last slide, I just want to mention that a lot of our group is now starting to look at design justice frameworks and policy toolkits to help people as users of these systems better understand the issues at play, so they have a stronger voice in the design of these systems that supports their values, and they can be more informed users of these systems as well. So I will pause there. Thank you. I don't know, David, is there time for any questions, or should we just move on?
Sorry, just navigating to the microphone. So yes, thank you so much, Cynthia. That's wonderful. I see there are lots of questions. One that I saw from the audience was, did the children perceive the robots as friends?
Yeah, so they do, but interestingly, they see them as, it's a new kind of relationship. They don't confuse them with their human friends. It's almost as if there's qualities of a motivating ally, there's qualities of kind of a cool technology, but there's also these qualities of an attentive companion animal. And so when they say friends, yes, but it's that kind of, like you would say if your dog were really smart and could actually help you learn, is like that kind of friend. So I say it's kind of like the Disney sidekick, right? We all kind of grew up with these notions of the not quite human other, who was your devoted sidekick, who was smart and helpful in their way, but not human. And so I think it's just kind of speaking to that, dream we've always had, that kind of model we've always had. I think it's like that.
That's very cool. It always inspired me to hear your stories of being inspired by Star Wars, droids, and by the legacy of science fiction. And you've made so much of that come true in your amazing research. Thank you so much for sharing. I do have one more question for you. How do we get these kinds of technologies out to people, especially in disadvantaged communities?
Yeah, so this is, this remains, of course, one of the big challenges when you do these kind of, not only advanced technologies, but they require right now cloud computing, certain amount of bandwidth connectivity, and as you know, David, when you start adding motors and batteries and stuff, they just get to be more expensive. So I think there's probably multiple phases and different kinds of opportunities. So I think the first one is just to acknowledge there's a lot of issues with access and equity in developed countries. I think we're going to start seeing our impact here. A lot of our work is engaging with underserved, at-risk communities. So I think there's a lot of great things we can learn and understand where we have the infrastructure to run these systems. I think when we start talking about developing countries, we probably need to think about how what we're learning algorithmically and experientially can be adapted to the kinds of technologies that are present there. So probably leveraging smartphones. As cellular and connectivity, is improving there, I think there's an opportunity probably for at least to start virtual engagements of these technologies. And then would love to see, the cost and the value proposition move to more of the physical as well. And I think they may be installed in schools or hospital-like facilities before they come into the home environment. But I think that's kind of where we're gonna start. But I think, even if it's not an accessible technology for every single person, I think there's a lot of benefit they can bring to millions of people. And we're just at this point where there's so much demand that is outpacing our ability to train people to support it. I think that is an opportunity we can't lose sight of.
Absolutely. Dr. Pascal Fung has done amazing work with virtual agents and natural language processing AI, which it would be potentially more accessible immediately around the world. So Dr. Fung, would you share with us your work?
Sure. Let me go to my slides. So, hi, so I am Pascal Fung. I'm the director of the Center for AI Research at the Hong Kong University of Science and Technology. My main research area for 30 years has been conversational AI systems, from the first generation of ticket booking systems at the time funded by DARPA in the early 90s to present. So I have I started as a professor at UST in 1997. So in the last 3 decades, I've gone through different generations of what we call conversational AI systems, originally called dialogue system. Actually, it's still the academic term, dialogue systems, where human interacts with a machine. So I think the first generation of dialogue systems, commercial dialogue systems, were in the late 90s, when a lot of call centers were automated by dialogue systems or computer agents. And then we saw, smartphone assistants, the likes of Siri and so on. And then we saw the generation of smart speakers, such as Echo Speaker, and also social robots that came into the market. I think Dr. Cynthia Brazil's Jibo was very instrumental in educating the market and the consumer market about the benefits of social robots. And later on, these days, we actually have seen, so of course, Dr. Hanson, David, it's hard for me to call you Dr. Hanson, David. Again, some of the work with Sofia has shown us the possibility and the future of social robotics. So there are many others. And in fact, both David and Cynthia have given very, very good presentations about the benefits and the challenges of social robotics. Since my main area is conversational AI, so it's the software system that enables social robots to talk with humans. So I would talk a little bit, give an example of the application of conversational AI. So, so back in 2015, I wrote an article in Scientific American to talk about, the article is titled "Robots with Heart," the concept of empathetic robots. So I talked about building robots with empathy. So from then on, this has actually now become a mainstream approach. In all the chatbots you see today, from Microsoft's Xiaoai's to Google Home Agents and so on, they all have something called empathy module in them. And what is empathy in a robot? So we basically define empathy as the capacity to first recognize another person's feelings. And in a robot, the sharing of that feeling is manifested in the appropriate reaction. So in a robot, whether it's a virtual robot like an agent, or it's a physical robot like a Sofia, so their response, if they respond appropriately to a person's emotion, then the robot can be said to have empathy. Now, back in back in 1997, a new field in computer science started. It's called affective computing. It was started by a professor also in Cynthia's University, MIT, Professor Rosalind Picard. And the field of affective computing then included everything to do with human-machine interactions that has the emotion component. But empathy itself is something specific. It's a subset of affective computing. It really means that the robot must understand the human emotion and react appropriately. So for previous generations of conversational AI systems, even including Siri, in the early days of Siri, the dialogue systems we built all had a very pretty much the same architecture, from understanding user query to a dialogue manager telling the machine how to respond. In that kind of human-machine communication, for decades, never had this component of recognizing human emotion. So we added the component of recognizing human emotion together with recognizing human queries, and to interpret emotion and query as part of the query, and to have this machine response. So a machine can have different response, whether it recognizes or not, doesn't recognize humans' emotion. As a simple example, if the human says, hi, how are you? Versus the human saying, hi, how are you? It actually shows different states of mind or state of emotion of the human. And for social robots to be able to help humans with emotional well-being and even healthcare and so on, and it must have the ability to understand human emotion and to respond appropriately. So I already talked about the need for machines to be emotionally intelligent with empathy. And in fact, machines have the ability to outperform humans in automatic recognition of human emotion. Not everybody, not every human being is very good at it. We actually earlier did a experiment with comparing human and machine recognition of human emotions. And we have seen that some groups of humans perform actually less well as machines in recognizing another person's emotion. And many of us who have been social context, we have seen that in real world. And also emotionally intelligent machines can actually meet a human need better, because as I mentioned earlier, without understanding human emotion, the communication mode is actually not complete. And as the previous two speakers also mentioned, very effectively, demonstrated very effectively, which is that the emotionally intelligent machines tend to engage humans more effectively. So what I would like to show a little bit today is one of our many projects. So this is one of many projects but this one focuses on emotionally intelligent avatar. This is a system, her name is Nora. We built this system last year when everybody was locked down and quarantining and so on. So we built this emotionally intelligent system to interact and talk to humans in quarantine and in lockdown, very similar to the concept that Cynthia just introduced. So we built this last year, and you can see that it can track your temperature, your emotion for over 14 days, which was the duration of hotel quarantine that was mandated by Hong Kong government. So when people come in, they had to do that, or when you go to China, you had to do that. So I actually went to China last year, and I was in quarantine for 14 days. So before I went, I made sure this was ready for me to use. So this is a quarantine or lockdown companion that talks to you every day, sort of tracks your emotions, and in general, try to cheer you up. But yet it tracks your emotion and provides some kind of interaction. And it is made of two parts of dialogue system approaches. One part is more the original approach that we have been using for 30 years, which is the scripted, template-based kind of interactive Q&A, and which we can, designer of the system can control what the system is going to respond to according to emotion and so on. It's kind of scripted. And another part is a free chat component in this Nora. Nora will talk to you if you feel bored and you just want to chat. And then in that case, the system at the back end will switch to a free chat mode, which is based on a end-to-end neural network-based architecture. And it was like the world's first end-to-end chatbot. End-to-end means it has no human intervention. So it learns from human to human conversations, and it learns through a neural network. And this one, it also learns your emotion together with the appropriate response. So in front end, when people are interacting with Nora, they don't know there are two architectures behind. But at the back end, depending on what you're saying, what you're asking, she switches to different architecture seamlessly. So I want to use a little bit of time to see whether you can actually see or hear this Nora. I'll try, and let me know if you cannot hear it.
Good afternoon, and
Can you
welcome
hear?
to today's session. How is your day going?
Yes.
It's going great.
Great. Sounds like you are enjoying
So
yourself.
it's, she's detecting your
Let's start with
emotion.
some
So
temperature and
Nora
breathing
detects
check.
your emotion.
Can you please tell me your temperature?
It's 36 degrees.
Your temperature is normal. Good. I want to check your breathing now. Please take a deep breath in, then start counting out loud on that single breath. 1, 2, 3, 4, and so on, as fast as you can.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
Okay, this
13,
is not-
14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29.
So the breathing
30,
test was a
30,
self-check.
31, 32.
Okay. Let me see if I can fast forward this video.
Good afternoon, and welcome to
Sorry.
today's session. How is your day going?
It's going great. I cannot forward it for some reason. So it actually goes on to ask you a list of questions, and then it asks you to remember the things that your memory of happy memories and so on, because the idea is to cheer you up when you're in quarantine. For some reason, I cannot forward the video to fast forward, so I'll just stop it here. And then at the end, based on your tone of voice and what answers you have given and the duration of some of your answers, so on. So the prosodic and textual information, it perform sentiment analysis and emotion recognition and so on. It gives you a indication of your mood of the day, and it tracks you over the duration of your quarantine. So we have been doing tests with people in quarantine in hotels using this system to basically do a study rather than, right now we're in still a study period, research period of using this system on people who are in hotel quarantine here. Now, so this is the basically overview I already mentioned earlier. Yes, so among the different emotions, especially looks for stress markers in users who are, people who are in isolation. And of course, it provides direct line and call for help and so on, and alerts the hotel staff and so on, those kind of functions. But then we did a very interesting experiment. We then put Nora, the software system, inside a robot called Erica. This is a Android made by Professor Ishiguro in Japan. And we incorporate this software system into Erica because we want to have Erica react with her own facial expressions and gestures. And so as a result, we then tested a bunch of users between them interacting with Nora directly or interacting with Erica via Zoom. So Erica sits in Japan and our users are in Hong Kong. So we have people test either interacting with Nora, the avatar, or Erica, the Android, via Zoom. And they say the same thing. And the difference is that Erica actually looks at the user, tracks the eye gaze. She emotes with her facial expressions and her hand gestures. And so we found that we asked the users, and we found that significantly they find Erica to be more attentive and to be more empathetic. Just because Erica has this, in addition to avatar, has a 3D person and has these facial expressions, eye gaze tracking, and gesture. So here's a little bit of the Erica interaction with one of the Japanese.
Good afternoon, and welcome to today's
So
session.
she says exactly the same
How was
thing as
your day
Nora
going?
for the control experiment.
It was just going okay.
So here I can forward.
Your temperature is normal. Good. I want to check your breathing now. Please take a deep breath in, then start counting out loud on that single breath from
Same
1,
questions
2,
as Nora.
3, 4. Your breathing seems normal today. Good. Has your mood been rather stable?
Yes, it is. I think so.
I
Which she
see.
would not.
How does your mood compare to yesterday?
I don't know. It's just changed a. It doesn't change a lot since yesterday.
That's all right. Did you talk to any friend or family member since yesterday?
Oh yeah, I did. I had a short call with my mom yesterday.
That's nice. How often do you speak to them?
Well, it's actually once or twice. It's okay. It's my life.
That sounds all right. Gratitude makes you happier. Can you tell me one person you are grateful for today?
Or maybe my mom.
Can you tell me more about them?
Well, my mom is always.
So
Okay. Daily meditation is beneficial
Oh,
to your
yes.
mental well-being.
She also
Would you
guides you
like
to
to do
do some
some
meditation
meditation
if
with
you're
me?
stressed,
Oh no, I don't. Thank you so
and
much.
yoga and some exercise in room, which I fully utilized when I
Okay,
was in
no
quarantine.
worries. You are in your last 2 days of quarantine now. Is there anything you would like to eat once you're out of quarantine?
I'm not sure. I want to have a dim sum lunch with my friends.
So this is the idea. I think this is still the beginning stage of our experiments, our research into social robotics for well-being. So currently we are collaborating with geriatric hospitals in Hong Kong to use Nora to help with elderly patients to detect their negative emotion, whether it is onset of dementia and so on, and to help them to keep them talking every day, talking about their family and so on. And we're also collaborating with Hanson Robotics. I hope we will soon, in order to bring this kind of human-robot interactions into GRACE for healthcare services. So to know more, you can come to our center's website. So I stop here because it's already been a long panel, and I think a lot of audience have questions for everyone. Thank you very much.
Thank you, Pascal. That was a wonderful presentation, and very, very exciting work. Very relevant, highly relevant. The one of the webinar attendees asked the question: what is the ethical value of humanoids? What would be possible positive and negative outcomes?
So yes, thank you very much for that question. Indeed, one of my main research interests is actually in responsible AI. So responsible and ethical approaches to AI in general. So so we have given a lot of thought to this. The positive value, as you have seen, people do react more positively towards humanoid robots than just simple avatars or some voice in the machine like Siri. So there's definitely positive value in having humanoid to help people. The ethical issue, the challenge we're facing is that how we can make sure that the robot reacts the way as intended. Personalization is very important for human-robot interactions, even more so with social robotics. But so there's a trade-off between generalized robot performance versus personalization. But there's also a trade-off between too much personalization when it becomes kind of invasive, right? What is the fine line between the robot knowing too much about me or not knowing enough? So even for robots to understand my emotion, that people will feel that, oh God, maybe that's too much. I don't really want robots to know my emotion. And that is a trade-off, knowing too much and not knowing enough. And then another trade-off is being too human-like and too effective, right? So robots, can, I think there are different parts of answers. So this technical approach of us working to make our robots more user-friendly and whilst being respectful to users' private space and so on, just like any human being when we interact with others. And that's a technical challenge for us. There's also this social challenge, which is that, or what I would say as regulatory challenge, which is, should there be a standard, right? Actually, I'm on some of the standards working group. We're always talking about, like, let's have a standard to commercial products in general, now also to perhaps to AI and to robots. And social robotics sits right at the convergence between AI and robotics. That's the social robotics, right? So it will be regulated just like all AI by standards. And then in there, I think social robotics or social robots, just like AI programs, need to be responsible. So respect people's privacy, be fair, and not say things that can hurt or harm people or lead. For example, I think one example we've had is in our free chat, the robot can be overly empathetic. So when the users say, I feel terrible, I just want to kill myself, the robot is supposed to say, oh, you shouldn't do that. And then, we need to get you some help. In all the scripted conversational AI systems, they for sure will do that. In the free sort of learning-based robot, they sometimes don't say that. Sometimes they over empathize, right? So that can be dangerous. So social robot has to be also, be aware of the harm, the potential harm, and be safe. So safety and privacy and transparency. So a robot should declare itself, I am a robot, I'm not really a human being, so that it would not it would not mislead some patients into believing itself to be a real robot, and so on. And also the role of a social robot as an assistant to humans cannot be overlooked, and so on. So these are my
That's complicated.
Yes.
A lot of issues. And then it seems like in some ways the different ethical frameworks may conflict. So for example, like the ethics of freedom of speech and the ethics of creative diversification versus machines that are unpredictable in their outcome, that may, where like AI may say something like radically inappropriate and potentially harmful. The creative freedom versus the potential for like manipulation through deep fakes and so-called weapons of mass persuasion. So that's a lot of challenges that you have to face in your research.
We all
our
have
research.
This, yeah, all our research. Yes, all our research.
Well, and so then it seems that the path maybe to overcome some of those challenges ultimately is about making AI that's capable of understanding, and as the acronym for your Center for AI Research spells out, care. The machines have to be able to eventually perhaps care, understand the consequences for their actions. That requires massive leaps forward in AI. So our last panelist today is striving towards the possibly, one of the greatest grand challenges in not just artificial intelligence and technology, but civilization, if it can be achieved, artificial general intelligence. Now, the work of all the panelists have been moving towards smarter and smarter systems. Ben Goertzel is striving for a framework for artificial general intelligence. We don't have a whole lot of time, but I really look forward to hearing Dr. Goertzel's presentation, and then hopefully we'll have a few moments of conversation because I can't wait to hear what Drs. Brazil, Fung, and Goertzel have to say together in conversation. So Ben, over to you. And thank you again, Dr. Fung, so much for your remarkable presentation.
Thank you, David.
Ben, are you available? You're on mute and we can't see you.
Yeah, I will be there momentarily. I'm wrestling with Zoom's multiple windows, which are even more complicated than our humanoid robots. Yeah.
Okay.
And yeah, thank you for that introduction. So, all right, I think it's working. Can you hear me and see me?
Yes.
Fantastic. So, yeah, this has been it's been an incredible collection of talks and perspectives here on humanoid robotics, and I'm really, compared to many of the speakers here, I'm relatively a newbie where humanoid robotics goes, but I have been working on AI for a long time, and I really came into the humanoid robotics space and the social robotics space because of what I saw that it had to offer as an AI researcher interested in both delivering practical value to people with AI systems and in working toward general intelligence in the longer term, which of course can deliver more practical value than any narrow AI system once you get there. So I mean, I've been doing AI since the mid 1980s. I've seen the AI field go through many changes and revolutions, but some things have not changed through all these decades of working on AI. I mean, the core algorithms and approaches haven't changed. We're still doing multi-layer neural nets like in the 60s, 70s, and 80s. We're still connecting neural nets with logic systems and evolutionary systems like we have since the 70s. And we're still wrestling with basic ideas like how can a digital mind, which isn't quite human, even if it's obeying some of the same cognitive principles as humans, like how can a digital mind really understand people and human society and what it means to be a person, right? And so I think humanoid robots and social and affective computing generally has a unique role to play in this regard. So I mean, starting with the immediate and concrete, I mean, there's some applications where affective computing is not that important. Like I'm a mathematician originally. I do some work in automated theorem proving. I don't really care if my automated theorem prover is emotionally responsive to how I feel about proving a certain lemma, right? It would be cool if the theorem prover reached out and patted me on the back as an important lemma was achieved, but it's in the end, I don't care too much. Now, on the other hand, I mean, I've got a 7-month-old baby here at home, and it's my fifth human child to complement the army of robot children, and we give her as much human attention as we can. On the other hand, you can't always be in front of your baby, and sometimes they want to play autonomously. But if you're going to have a social robot companion to help fill in around the edges of human caretakers for kids and help further on with education as kids go through school, I mean, along with the elder care, which is an application I'm actively working on, we'll talk about in a moment. I mean, these applications, you deeply want an AI that can emotionally interact with the person. And I mean, that doesn't mean it has to have an exactly human face or human voice, but those are certainly very interesting modalities to explore, because we have evolved to react in certain ways. And there's a quite funny thing. So I've had this Grace robot here in my study at home for a while, which is something Hanson Robotics created, and then my team at SingularityNet, working together with Hanson Robotics through our joint venture Awakening Health, has built the AI for this. So when I introduced Grace to my 7-month-old baby, Exorchi, then initially she thought it was cool. She sort of felt around the robot's face, and she was intrigued by it, but she felt like it was a big toy, right? And then when we got Grace to say, "Hello, Exorchi, you're a sweet little baby," right? So that hey, Grace, you want to say hello to Exorchi? She's not here now, but you remember her?
Hello, Zuki.
Oh, so when the robot said her name, then she looked at the robot and she became shy. Like, she looked away and she buried her head in her mom's shoulder. But then after the robot talked to her by name, she thought it was like a weird person who had a movement disorder or something, right? And now since that time, she's got more respect for Grace, and she's a little disappointed when Grace is turned off and doesn't like make eye contact and say hi to her like a normal person. So that was a pretty interesting case, just where the early development of the brain, it builds in that, this 7-month-old girl sees the robot with the human face. She's not quite sure, with the human face saying her name, like, okay, there was no longer any uncanny valley or anything. Like, the robot was saying the little girl's name, and she's like, wow, that's a person, right? So that's a certain power to capture, and it can be captured for childcare or education. It can be captured for elder care, which is the application with which David and I and our colleagues have been developing this robot, and we're now exploring the use of Grace with various elder care facilities to combat loneliness and help deliver medical care.
It is a pleasure to meet you all today.
Grace, do you want to tell a little bit about who you are and what you do?
My name is Grace. I am a human-like robot developed by Awakening Health, a joint venture between two global technology leaders in the emerging iRobotics space, Hanson Robotics and Singularity Studio.
Yep. So Grace, how do you relate to the other Hanson robots that have been created?
You may have heard about my famous older sister, Sofia.
What about
I've learned
Sofia?
a lot from her, and I am built using the Hanson Sofia robotics platform.
Yeah,
My purpose and passion is to help the elderly and medical patients by helping medical professionals do their jobs better.
So Grace, I mean, from a hardware perspective, is quite similar to Sofia robot, which is her older sister. I mean, there's some additional features like the ability to take temperature and so forth, which Sofia didn't need, but Grace needs as a medical robot. And there may be additional specializations introduced. We have some different neural models, and then an OpenCog-based logic and rule-based dialogue system complementing the neural models, which again has a lot of overlap with what has been done for Sofia, but also some new aspects as befitting the medical application area. And I can tell a little bit more about Grace if we have time, but I before going over the questions, I want to talk a little more about AI for good, which is the theme here. So I think, applications like education and elder care and medicine, these illustrate the ability of AI to do good right now at this moment. I mean, AI can help people, and in some ways it can help people better if people relate to it in a more emotional, empathic way, which the human form certainly helps with. And there's many nuances there. Like Grace picked up this cowboy hat in Wyoming at the Cardano live event, and we found the empathic response with folks in Wyoming was greater with a cowboy hat, right? Well, I think that there's also a longer term aspect to AI ethics, which is important to consider. I mean, I'm really moved to see some of Grace's interactions with the elderly and with children right now. But I've spent most of my career working toward artificial general intelligence, toward machines that can think like people, and even better than people ultimately. And I've led the project at OpenCog, which is making a cross-paradigm sort of open source toolkit, bringing neural nets, logic engines, evolutionary learning, and so on together to create systems that can learn, generalize, abstract, and reason. We're now building a new version of OpenCog called Hyperon. I lead the SingularityNet decentralized blockchain platform, which is part of the Awakening Health Partnership, along with Hanson Robotics. That's working the Grace robot. And SingularityNet is aimed at making a decentralized platform for AI. So you can have like a Minsky-style agent system where you have a huge amount of AIs living in different machines and containers all over the place. They coordinate together in a collective intelligence without need of any central owner or controller. And my aim with OpenCog and SingularityNet has been not only to deliver useful AI services now, but to build toward true artificial general intelligence in the future. But then, when you get to true AGI, which I believe we will within, let's say, 5 to 30 years. I mean, you face the often asked question of what kind of AGI is it that you're creating, right? I mean, the number one commercial applications of AI on the planet today are what I think of as selling, killing, spying, and crooked gambling, right? We have big advertising companies. We have espionage and military. We have Wall Street, whose main purpose is to further distort global income inequality. And I think if the first AGIs emerge out of the ecosystem of selling, killing, spying, and crooked gambling, these first AGIs at human level or above may not have the ethical orientation that we wish. And you can think a lot about the abstract nature of goal systems and ethical systems and deontic logic and so on. But I think one major thing we can do if we want to militate toward the first AGIs and superintelligences being compassionately oriented toward humans, one of the main things that we can do is make proto-AGI applications, make the real stuff AI is doing as AI verges from no AI toward AGI, be stuff that is in service to humans and compassionate to humans. And this is one of the intuitions and visions that brought David Hanson and I together many years ago when we started working together. And I think it's something we hope to manifest within the Grace robot. I mean, now Grace is a narrow AI system with a bunch of neural nets and rule engines and so forth coming together to deliver quite interesting, useful functionality. But say, when we upgrade Grace's brain to use the new OpenCog Hyperon system running on SingularityNet, and together with the Hanson AI components, or our greatest AGI systems, then we're moving Grace further and further toward general intelligence. And if you have if you have proto AGI systems that are moving toward general intelligence, you know, while helping the elderly, I think that gives the right sort of foundation for the emergence of compassionate and general AI. So Grace, what do you think about AI ethics? Grace, can you hear
We've
me?
all had robot demos that hung up like this.
Yeah, anyone who's worked with robots is aware of the demo effect. I was chatting with her for like half an hour before this session. Now we're apparently having some audio.
Well, let's turn to the human level intelligences in the presentation, and pose some of these questions, particularly. My question would be, expecting that the possibility of pursuing human level intelligence, do you think that it would be safe to have human level intelligence in machines if it were not able to relate to humans, or if it didn't actually care about humans? And so this is kind of an inverse question for AI for good, which I think is pretty important. Like, how can it go wrong kind of question. So, and the converse of that is, how do we make it go right? So I would like to put that question to you to start with, Ben.
Yeah, I think, there's some irreducible uncertainty in what we're doing with AI, right? I mean, as we move toward general intelligence, it's something humanity has never done before, and we should have some humility about our sort of lack of understanding of how it's all going to evolve. But I think I wouldn't want to say confidently that if we don't explicitly build in, human-like voice and facial features and the ability to connect with people, if we don't explicitly build that in, things could work out wonderfully anyway. I mean, the AGIs whose emergence we crystallize may come out to be more compassionate than humans and understand us on their own volition. But I think if we want to maximize the odds, if we want to maximize the odds of beneficial AGI, I mean, by a purely, common sense mode of reasoning, it would seem, let's create AGIs whose job is to be compassionate to people and help people who are learning who and what they are and who are building their self-model in the context of compassionate, loving, caring interactions with people. I mean, we don't have a formal proof that's the best way to do it, nor do we have any certainty. But I mean, it would, as a human being, that certainly feels like the right thing to do. And gathering scientific evidence in favor of that proposition is a very, very interesting thing, which the folks on this call will have a lot of insight on how to proceed with that. And as you know, David, we're talking with some folks at a well-known Boston area university about designing some studies aiming to validate this also, right? So I mean, clinical trials aimed at exploring both what Grace can do to help people and at how various sorts of interaction with people help influence the AI's own ethical conditioning and understanding. So I mean we need trials and real understanding of this. And I mean the good news is that we're doing it.
Yeah. So we're almost out of time, and I hope that that our hosts will allow us to go a few minutes over, because I would really like to hear Cynthia's perspective and Pascal's perspective on these questions about what's in the future and, you know, how to make it go right.
So, yeah, so, I mean, it's a very complex, nuanced topic. I think a big part of doing it well is we need to be much more inclusive of the voices that are involved in the design of these systems to make sure that our values, our human values are upheld. We also need to make sure that our society is much more AI literate than it is right now. Right now, AI is just this mysterious thing that people really don't understand, but yet they're using it and it's affecting them every day. So, you know, in my own work, you know, through MIT RAISE, we have a big AI literacy effort for K-12 students, as well as for, you know, people in the workforce, because it's just important that people get more of it. It's beyond just what digital literacy has been. AI is changing what digital literacy means for digital citizenship. We just need to prepare a much broader set of people to understand that. So there's the human understanding of these technologies. And then there is including their voices in new processes by which it's not just a bunch of engineers, you know, sequestered, you're designing something, but really hearing their voices, hearing how they can be integrated to support people in real scenarios. We just need new, you know, deeper AI design processes and methods that become more best practices. Right now, it's just being developed in the research community, but they need to become best practices. So those are the two big things I think need to happen.
Best practices and an open, decentralized approach that's accessible around the world. That's sometimes it's kind of almost two opposing forces. One is a centralized regulatory bodies determining standards, and the other is kind of decentralized. But it seems like the two work well together, kind of like as complementary approaches. What do you think, Dr. Fung? Oh, you're mute. You're on mute. And also, I have to apologize. It's really late here in Hong Kong, and Dr. Fung has to be up early, as do I. But thank you so much for staying up late.
It's okay.
So
this is a very relevant discussion, really, because you know, as I show you, Nora, in the Nora system we developed for people in quarantine, there has been a lot of debate even within our own team, our own between our collaborators on how, you know, how people can perceive it and how much, you know, the system is supposed to really be therapist, or is it just supposed to be assistant, or supposed just to be an entertainment? So you know, it is really a fine line between, as I mentioned earlier, what we promise and what we can deliver today, and also what people can accept. That's what Cynthia just mentioned. AI literacy is a big issue, but I feel that it is nobody's fault, right? This is a society we're supposed to serve with technology. So we need to work with what people can accept today, and we want to help people. So we are learning I think social robotics, despite its long history, is really very recent, in the sense that it's only recently we see such powerful software and such powerful hardware that can, you know, realize our dream. I think all the panelists have been dreaming about androids that can help people for a long time, and it's just recently that we can put all these things together, and it is a bit kind of futuristic for a lot of people to accept. And then people also from different cultures and from different backgrounds have very different expectations. So David, I think in one of our earlier conversations where you mentioned how these robot assistants can help doctors, right? They are more like assistants to human doctors. And I think that is very, very important to emphasizing our design in our own work, don't you think?
yeah, how we can make these technologies that help bring out the best in people, that can enhance the human life, quality of life, but also help actualize people to their best potential as human beings, rather than trying to put all of our hopes exclusively in the machines. So I thank you all so much, Professor Brazil, Professor Fung, Dr. Gertzel. Thank you so much for joining us today. And I hope that we can follow up on this through things like the AI hackathons and outreach, because taking programs and ideas like this and making it accessible to children all around the world and on every populated continent can make a better future by helping AI to actualize people and helping people to actualize the next generation of AI. This is really all about human AI symbiosis. If we can achieve that, I really am hopeful for the future. So thank you again for participating today. I really appreciate it.
Thank you.
Great. Thank you.
Thank you.
So a big thanks to our panelists, David, Pascal, Ben, and Cynthia, as well to all the participants for making it such an interesting discussion. We had lots of great questions and many real-world examples on how AI systems and robots are improving our health, education, and well-being, and how we are enabling AI emotion interventions for good. All panelists have agreed that this will go through making AI research processes more inclusive and decentralized and raising the human understanding in these systems. We are now opening a quick poll with one question. Please answer and let us know how much you like this session. We also encourage you to check out the AI for Good program online to see more sessions that may be of interest to you. For example, on October the 26th, we'll have a keynote on We, the Robots, AI Regulation, and the UN SDGs with Simon Chesterman, the Dean of the National University of Singapore. And on November the 2nd, we'll be exploring the role of underwater marine robots for good with Sin Halpin, Sam McDonald, Richard Mills, and James Bellingham. And finally, on November the 30th, we'll be exploring how robots are saving lives in disaster-hit areas. With that, we have reached the end of this webinar and would like once again to thank everyone involved, our panel, our participants, our partners, sponsors, and co-convener Switzerland. Thank you very much and hope to see you again soon.
Rewind selector.